Hello, my name is Yaya, and today I look forward to introduce to you HTZ Automation, one of the latest products that we have under ATDI. So, what is HTZ Automation? So, HTZ Automation is a web interface which is capable of automating repeating tasks. So, you can design workflows, you can create a story timeline, you can create stages or tasks or steps, and you can decide on the dependencies, and you can actually easily design a workflow um, with the ability to define the inputs and the outputs, and you can access the input and the outputs via API. So these workflow become reusable, and it can be shared, and it can be executed based on a certain trigger or schedule. So what we did is actually we constructed the software stack. So this is the entire solution. So it is based in the core on HTZ communication or HTZ warfare. So at the very bottom, we have SQL server or SQL database, any sort of database that we can use to exchange base station information, base station parameters, and the coverage predictions and so on. So this is an existing feature. HTZ can already talk to SQL. So the idea is that the network is captured in SQL table, and then we apply the analysis. So HTZ is exchanging with SQL, which means here third party can also be exchanging information with SQL. So that's how HTZ can get a latest snapshot of something. Now HTZ communication is automatically engaged and operated by a server, an agent. We call it HTZ web server or HTZ agent. So the agent is the one translating the user input, which is coming through a web interface. We translate it to HTZ action codes, and it prepare the inputs and the outputs and does the interface. So in fact, the clients at the very top, the clients or the end users, they just need to use a web browser in order to communicate with the solution. Like for example, they could be designing workflows, or could be executing or scheduling a certain complex job for execution. And once the task is scheduled and it's time for execution, HTZ server will assemble all the information and will execute HTZ on the server. And then HTZ will use the data passed from the web server and SQL and get it done, and then push the output back to the server. And the user can be notified by email, or actually can use API to download the output. So what is exactly the HTZ automation? It is a web interface. So it's a solution which we can deploy on the cloud, or we can deploy locally on the network. The web interface has an authentication and authorization mechanism. So which means you can create policy groups, and you can create credentials, and you can create cookie in order to control the access. It's a multi-user environment, meaning that you can have more than one user using the system at the same time. If you have two people doing different tasks, they can schedule different tasks, and then the server will manage these tasks based on the priority or based on the timeline. You can design workflows, and you can create complex jobs. So complex jobs, for example, you could be doing coverage predictions at 1.5 meter, doing coverage analysis for the handheld, and then doing coverage analysis for the drones, and then exporting best server, and then doing statistical analysis. So you could create a story, or we call it a recipe. You can create a recipe made of multiple building blocks or multiple jobs. So you can schedule jobs once or daily or weekly or monthly, whatever, and you can send notifications when it's done, and notifications coming with a link where you can download the output directly. The output could be a KMZ, for example, or a TIFF or a CSV file, depending on the analysis you're doing. You can get status or progress update. You can see where we are, who's in the queue, what users accessing the server, and so on. You can download the simulations in a KMZ, TIFF, and CSV format. You can upload new files. Okay, so if you have a new project in another country or in another location and you want to reuse the same workflow, so you can effectively load or preload the layers, the files, terrain, clutter, PRM, palette, wherever, and then you can use them as an input to this recipe. And because it's a web interface, you can access it from your tablet, from your iPad, or phone, or computer, whatever. So it's a web interface completely compatible with Firefox or Chrome or FileZilla and so on. Now that's for the web interface. So HTZ communication is usually running in the background on a server. So the same server, or it could be different server, hosting the web server. You need to have enough specs, and then the agent will assemble the information and then run or engage HTZ. So you can run usually multiple concurrent jobs, depending on the dependency. So if one task is dependent on another one, so we have to wait for the first one to complete to kick off the other one. But effectively, you can do multiple analysis in one go, and that's possible if you have multiple licenses of the software, and it's going to speed up your work considerably. Now the web server, this guy, basically it's HTZ agent. Like I said, it controls HTZ, and it does all the low-level communication with HTZ. We have scheduler in this solution as well. Scheduler, queue management. You can cancel a job from the queue. You can queue in queue, dequeue a job, and there is file system management as well to handle the layers like terrain, clutter, KMZ. So you can keep multiple versions of it, the historical data, and we can also control the access level. And like we said, we have the API capability if somebody wants to extract the latest simulation from the web interface via the API, which is RESTful architecture. This is an example of one use case of this solution, is to create three jobs, two stage. This is two stages, 1 and 2. Now in that stage we're doing coverage predictions, and in this stage we're doing RSSI analysis and best server analysis. You could do a lot more, okay? And you can have other dependencies as well. But here you see the RSSI has to wait for the coverage to finish to be able to do the analysis and extract the KMZ files from the composite coverage effectively. Now these two jobs, RSSI and best server, do not have to wait for each other's, so the server actually can run both of them concurrently. And that's where the advantage here, you can save time when you're running simulation. This big blue box here is the recipe. We call it a recipe. And these yellow boxes, we call them the building blocks, we call them jobs as well. These are the jobs or the action codes. So in HTZ terminology, we call them action codes. So each task is specified by action code, and the action code can take certain inputs and deliver the output. So we can pipe these different stages together and these different jobs together in order to pass the parameters. So we enclose this entire workflow or stages in one recipe. We call it a recipe. That one recipe has externally inputs and outputs. So the inputs are here the terrain, the PRM file, and the antenna height, the legend for the analysis, and SQL connector to extract the base station configurations. These are the outputs. Now the inputs. The inputs are distributed to using piping to these different stages or different tasks. So that task would require terrain, PRM, so we would grab them from the input. Okay. So during the design stage of the workflow, which doesn't require programming, you can just do it using the web interface. So you can customize this recipe to deliver the desired output. And you can see here the desired output in that case, simply best server analysis in KMZ and RSSI in KMZ. That's all. So this is what I wanted to explain to you about this solution. And definitely we have another video that explained the web interface a little bit more, how it works. But for now, I just wanted to give you really a high level understanding of this product and what it's capable of. Thank you very much.